So suppose you've taken out an amortized loan of some sort, and then you get a windfall of some kind, an inheritance, a lottery win. Note your professor does not recommend playing lottery, but that's beside the point. Um, Otherwise, I guess maybe if it's a business thing, your internet startup went nuclear, and now you're flush with cash or something like that. You get the idea. Somehow you end up with a lot of money, and you just want to go ahead and nuke the loan. Didn't mean to use nuclear in reference twice that fast. Anyway, so you want to go ahead and pay the whole loan off at once. So if you're wanting to do that, you're going to have to calculate what we call an unpaid balance. Alternatively, you might call it a payoff amount. I like unpaid balance better. That's just me. So the formula looks kind of like what we've already seen on some level. Note this subscripted n minus k, and then you have an n minus k appear here. This looks kind of like an annuity present value calculation, except for this guy right here. It kind of is. Anyway, so usual stuff. R is how much we've been paying. I's periodic rate. N is however many payments we initially set up the loan for. K is the number of payments that we've made in this setting. Okay? So that's what we're looking at this stage. So first example here, the debt amount ends up being really similar to our initial mortgage example from before. So the catch is we kind of have to play around with this a bit, because initially we need to figure out how much these folks are paying off, and then we use that inside this unpaid balance formula. So I tried to find a clever way around it, but I can't really. So it doesn't hurt to get us more practice with that amortized loan payment formula from last time. Okay, so we know A sub n is, once again, 170,000. We're given an 8% interest rate being compounded quarterly. So I is 0.08. We're dividing by 4 quarters. And that gives a periodic rate of 0.02. And then we have n equals, let's say, 4 quarters, and it's supposed to be 15 years. So 4 times 15 is 60. All right. So now we need to fill this into our amortized loan formula to get how much they're paying per quarter. Got ready to say month. Oops. So we have 170,000. We've got up top 0.02, 1 minus 1 plus 0.02 to negative 60. Close up those parentheses. All right, so we pound away on the arithmetic or the calculator buttons or what have you. When I worked that out, I got 4,890 and 55 cents. Okay, so that's how much they pay per month. That's part of the story. All right, now, after 5 payments, all of a sudden something crazy has happened and they're flush with cash and they want to go ahead and pay off the whole loan. So now we can fill R, I, N, and K into this formula to work out what's going on. So all of this goes away, and now I've got everything I need for this guy right here. So we had everything but K. It specified this happens after 5 payments. So we have A sub n minus K, 48, 90, 55. And up top, we're going to have 1 minus 1.02 to the negative 60 minus 5. Be careful with that. In any case, you should get negative 55 out of that guy right here. And then down below, we've still got I hovering around. So that's it. We just kind of hammer through the calculation. We don't need R anymore because we got it listed right there. And the amount that they've paid off is 162,000. Well, sorry, the amount they still need to pay off is $162,242.96. This can be kind of a sobering thing. Like I said, this whole chapter, or this whole section rather, can often come off as kind of a downer. So yeah, if you look at exactly how much they've paid in total, it's like close to $25,000, and they've actually only reduced the debt by like less than $7,500. So again, welcome to amortization. So, all right, I've got one last example I want to take a look at. So bear with me while I clean off this board one more time. We kind of end on a doozy here. So, remember Kate, the one who was saving up for a car and then had the college loan. This last example that we're going to take a look at doesn't specifically mention her, but I choose to blame her for what's happening at this point. So, if your name happens to be Kate, I'm sorry, I'm not aiming this at you. This is the fictitious Kate. Anyway, so Kate's borrowed $100,000. She had her interest rate given as 6% compounded monthly. It was originally a 30-year loan. We're given that her payments worked out to be $599.55 on a monthly basis. Somebody's already done us the solid of calculating the unpaid balance after she's been paying on this for 2 years. So 24 payments, she still owes $97,468.25. Again, kind of sobering. So after that, this is a little bit more than like the standard kind of windfall thing that I talked about. So, it amounts to somebody deciding to pay more than the minimum payment on their mortgage or student loan or whatever per month. So, assuming we can bump our payments up to $650, how quickly does that retire the, what's left of the loan balance? And then we're asked to figure out exactly how much saving that is. So, what we're going to do is fill these blanks into our unpaid balance formula and work out exactly how many extra payments we're going to need to make. So we have our A sub N guy there. So we have 97,468.25, and we have our payment R. And then over here on this side, we have 1 minus 1.005. I didn't actually calculate I real quick, so we had 0.06 divided by 12, so that's 0.005. So I didn't call that out. Let me be complete here. So 1.005 to the negative n all over I again. All right. So usual routine at this stage. To get rid of the 650, we divide. Whatever we do to one side, we got to do to the other. To get rid of this division by 0.05, I'm going to multiply by 0.05. Those go poof. All right, so I've got all that stuff over on the left, and now I'm kind of down to the exponential bit. So when I work this out again, I didn't round anything, but this stuff over here, when I worked it out, gives me 0.749758. Yes, double checking, making sure I did that right. Equals 1 minus this thing. We still need to get the exponential by itself. Subtract 1 from both sides. So the 1 goes away. I still need that negative. I tried that in the previous example. So 1 cancels away with a minus 1. I've got a minus 1 over here now, and that would give me something negative. Now I need to divide that guy by negative 1, so those go poof. I have to divide that whole thing by negative 1, and so now I'm looking at positive 0.2502442 equals 1.005 to the negative n. All right, so again, we've pounded away on this pretty hard at this point, but let's take a look at what's going to happen here. So let me jump cut one last time. This probably isn't too surprising at this stage. To get this n out of the exponent, we've got to take a logarithm. I like the natural log. Use whatever one you like. So ln, properties of logarithms say this minus n can hop out front. So I've got that. Now I need to get n by itself. Divide by this, divide by the negative 1. So ln, this thing to 0.250, 2442, divided by negative ln, 1.005. We can work this out to the nearest integer because it's not like a fractional payment thing. So yeah, we got to make 278 more months worth of payments. Okay, so Kate's still got a fair amount of loan repayment in front of her, right? Because these are monthly. This is still a pretty long, period of time. All right. So what I want to do before we call it a video here is figure out how much Kate ends up paying in total over the course of, repaying this loan. So she made 24 payments at the original amount. So that was $599.55 per what we were given. And then we've got to make 278 payments at the new value of $650. All right. So you can work out the arithmetic here. It's a lot. So $195,089, and I got 20 cents at this stage. So that sounds like a ton, and I'm not going to lie, it is. This is almost double what she borrowed in the first place, right? So yeah, that's what happens when you take out like a 30-year loan. So yeah, it does look good. What I'd like for you to do in the assignment is finish the job here insofar as see how much she ends up saving by adjusting her payment plan in this sense. So work out exactly how much she would have paid if she had just kept making those minimum $599.55 payments for the full 30 years, and see how much it ends up saving her. So good riddance, Kate. We're done with you. I've got one more video because I want to talk about some Excel stuff. So look for that right after this.